All right, so this is an extremely important exercise that we did for several reasons. A lot of what you're going to be seeing in the field is ladder diagrams. So your diagrams are going to be looking like this. But in reality, there's wires going everywhere like that. You're going to have symbols that look like this, but in reality, you're going to have three-dimensional components that look like that. And when you're diagnosing, you have to look at where you have power, where you're supposed to have power, don't have power, etc. And you're going to have points to test, and it's going to be looking like this, but in reality, it's going to be that over there. So this, what we did right now, is an extremely important step in the learning process. This is massively, massively important because this starts connecting that together. Follow me? Knowing that here it's a simple little wire that comes over, but in there that wire may be several feet long or 20 feet long. But it still connects from there to here, from here to there, from there to there, all the way back. That's how it connects. So in this exercise, there's a whole lot of examples here, but we're going to break it down and make it pretty simple. And if it's complicated for you at first, it's okay. It's your first time, right? It's your first time. It's not supposed to be easy right away. But the more we do this, and the fact you're actually doing it, you're getting your hands in there, and maybe the numbers didn't come out right at first, but you do it again. That's why we had plenty of time to make sure that we had time to really let this soak in, to do it, to start thinking about it. And as we do it more and more, it'll get easier and easier. All right, so first let's just do the one where it says closed all the way down. So if it's a closed switch in our diagram, then this will have to be closed, which means it allows electricity to flow all the way through. Of course, it's alternating currents, back and forth, but the electricity is flowing all the way through. So now, if I draw a little line representing my potential difference, is it going to be here or is it going to be here? It's going to be here. All right, so that's going to be our potential difference line. So everything, if I checked with my meter, where did my meter go? Here? There we go. So if I have my 2 points of my meter, and I check in any possible combination but stay on this side, it's going to show what? Zero. And if I check on this side, any possible combination, it's going to show what? Zero. And if I check across here in any possible combination, it's going to be 120. Good. That's the key to this whole thing. So we'll start off with the first one. The first one is between volts between A and F. So A and F, is that across this line? So it's going to be what? 120. Next, between B and C. Between B and C, is that only on this side? Yep, so it's going to be 0. If you're getting 30, it's because you left the power switch in the off position. It was back feeding through other switches and boards. So if you left that switch on, engaged, you will for sure have 0. All right, so with this pressed in, the contactor closed. Notice that contactor closed switch, and that device you had to push in, it's called a contactor. And when you had to actually push it in to close the contacts, it physically connects the contacts. That's how you can see it's a closed switch. You actually had to bridge those 2 points. So next is between D and E. Is that across? Yes, so that's going to be 120. A and D. So here's A, here's D. Oh, it's all on this side, so it's going to be for sure 0. Between A and B, it's all on this side, so for sure going to be 0. A and E. A and E, we're across, so 120. And C and E, that's across, so it's going to be 120. B and F, that's across, so it'll be 120. And A and B, all in one. Oh, these are amps. So amperage. Now it says between those 2 points, what do we use for amps? We use the clamp. Now there was several settings on here. This particular meter is an automatic. It automatically adjusts to what I need. The top number is reading amps, the bottom number is reading volts. But on yours, the one we're using, you have to set them. And there's a setting of 200, there's a setting of 40.
4,404.
No, but you're right.
And then there was this one that said the UA. This is microamps. We don't need that one. 200, we really don't need that one. Either one of these two settings would work. That make sense?
How come it didn't work with the microamps? It seemed like it would come up with a big number.
Because micro being 100, so it's adding. If you're checking amperage and it's reading in microamps, it's adding 2 extra zeros on it.
But it didn't read anything, it just read zero.
Oh, ours read the
Well, like I say, these meters, we don't let you use the nice meters at the beginning because people put them on the wrong settings. They put them on ohms and they hook them up to power. And should you ever use ohms when you have power? No, so they hook them up and it causes damage to the meter. So we use these cheap meters to get started with, so that way when you guys are, oh, sorry, it's okay, no problem with the cheap meter. Whereas it's going to be like my very nice and expensive meter. It's like, no, sorry doesn't cut it. It's my meter. So that's why some of them are different than others, because they get used and abused.
I would just expect it to be a really big number.
Well, you were getting what, 100?
Yeah, we got
Well, 100's a pretty big number when it should be half, and they're getting 100, so it was a pretty big.
Ours read zeros.
Like I say, the meter's damaged, so it's that's why. So if you set it for the right setting, now we're checking amps, and for amps is reading the electromagnetic field of that wire. So we can clamp it anywhere around the wire between A and B. Clamp it around the wire. You guys should have had something like 0.4 or 0.5, something like that. We're going to round it to 0.5, a half an amp. Now it says between C and D. 0.5. And between E and F, anywhere in E and F? 0.5. So notice that if I clamp it around the wire anywhere, it's going to be the same amperage. It doesn't matter where you clamp it. If it's on that one wire in that circuit, the amps are going to be the same. Because I can't flow fast here and then flow slower over here. Right? It's in one circuit, so it's going to be the same speed of electron flow through that whole circuit. Does that make sense? So far, so good? So that I just did this ridiculousness with all of these different numbers so you can see how the amps, doesn't matter where you check it on that circuit, that it's the same amps. So you can see it happening right there by doing it. Now the next side is we check it with it open. So once the switch is open, that's my break. So what happens to my potential difference line?
It moves back to the switch.
It moves over to the switch. So now that is my separation. So we'll start at the beginning. A and F. A and F, is that across my potential difference line?
Yep.
So am I going to have a number?
Yep, 120.
Good. Now it says between B and C. So here's B and C. Is that across my line?
Yes.
Yes. 120. All right, what about D and E?
0.
0. Does that mean there's no power there?
No.
It just means between those 2 points there's no potential difference. But if I was to touch that and touch ground, I could be electrocuted. What about between A and D? So here's A, here's D. Is that across that line?
120.
Good. What about between A and B?
0.
All on the same side, so it's going to be 0. What about between A and E? Here's A, here's E.
120.
That's across. It's going to be 120. What about between C and E?
0.
All on the same side. That'll be 0. B and F. Here's B, here's F.
120.
120 or across. All right, between A and B.
0.00011 was 0.
0. Sorry, that was amps. So amps clamping it around, that will still be 0 amps. All right, what if I clamp between C and D? Clamp it here?
0.
0. What if I clamp it here? 0. So notice that if my switch is open, can there be a flow of electrons? If there's no flow of electrons, amps means speed of electron flow. And if there's no flow of electrons, amps also means current. If there's no flow, there's no current. If there's no current, if the switch is open, can I have any current? Can I have any amps? Can I have any speed of electron flow? No. So it's one way, if you can't check to see if a motor's turning or not, you can clamp the amp meter around it, and if you're not getting any readings, you know the motor's not turning. Right? I can just simply clamp it around here. I don't even have to know. I can close, well, you can have it to where you can't see what's happening with the switch, and you can just look at the meter and tell if something's has current flowing through it or not, just by seeing amps. If I have 0, 0, and 0, right, it's not happening. Nothing's working. If I have a number, then something's going on. May not be good, maybe too high, maybe too low, but at least you know that something's going on. Something's happening. There's a complete circuit there somewhere. Does that make sense?
Yes.
You see how it ties together? That switch being open and closed?
Yes.
Okay, good. So what was our amperage? When it's close, 0.5, what was our voltage? 120. So let's put that into our app. I want to know what would my ohms be and what would the watts be. Don't call it out loud. Let everybody use the app and put it in the app.
Would you like to know what the what is?
Ohms and watts. Don't call it out loud. Good. I'm going to step right over your wire.
Oh, yeah.
There we go.
Good.
That makes a lot more sense. What did they want? I did it wrong.
Oh, I was like wrong, like I'm way off. So I was gonna say.
But the
Your current needs to be 0.5. Yeah, that'll make a difference. Volts, put 120, and current, put 0.5.
These right? The symbols?
Oh, yes.
Like they did voltage.
Oh, no. Point oh six.
That's all you need, a voltage and current.
Yep, just need two numbers. You can find all the rest.
What'd you get?
I got a point zero six in there, but I don't know how I know what.
You hit the 0.5.
You're in kilo ohms and milliamps. You need to change it to just amps,
Okay.
and then just ohms.
Breakers already.
20 amps.
No, I mean, I think there's. Yeah, why is your.
Hit calculate again. See if that.
Yeah, no, I did.
Check this out.
Yeah, you
Oh, did it? Oh, I had to leave them.
All right, let's see what we got.
I got a .06 and mine looks exactly like everybody else's.
Mine's .06 too.
Mine's 16.
It's a difference of 1,000. I mean,
There we go.
he's gonna take that.
Just erase it and just push that.
Let's erase the ones that
He told the calculator it's wrong, and the calculator was like, "You're right, I messed up."
and hit calculate, and boom.
It's like, yep.
There it is.
No, I did.
All right, so when we calculate it, it tells us that the ohms was what? 240 ohms of resistance. And the watts was 60. Okay, enter the numbers in right. Right, 60 watts. Oh, did anybody look to see what the wattage rating of that light bulb was?
Was it 60?
60 watt light bulb. What? Now, is it always going to be a 60 watt light bulb?
No.
Feel like 45.
Let's see what if we had 115 volts. Leave the ohms at 240 because the resistance going to change?
No.
No, so I'm going to give you two numbers. Ohms 240, volts 115. Volts 115, ohms 240.
55 I don't want to.
No, I need people to say.
I gotta make sure it's right.
Decimal point. You feel me? My decimal.
All right, so what was your amp reading?
479.
Point 47.
0.47, right? And what did the watts come out to?
55.
About everything.
So if I have a lower voltage on a light bulb, if I have a lower voltage going to that light bulb, what's it going to do to my speed of electron flow? Slow them down. If I have slower electron flow. With the same volts, what's going to happen to my watts? Less watts. What's it going to do to the amount of light that's coming out? Also less light as well. So it's not always going to be a 60-watt light bulb. It's all going to depend on your voltage. The higher the voltage you have, the more wattage it's going to be. So when they have that rated for so many watts, it's so many watts at so many volts. You change the voltage, you're going to change your outcome. Because what's not changing? What's for sure not going to change?
So they put in a light bulb based on 120?
Your ohms. Yes. Right. Does that make sense? Interesting? No? Boring?
Stay the same.
Okay.
Give me the right number at the beginning. That would be great. So I quit yelling out 479 when it's 0.479.
You know,
Trying to be nice.
I am a fantastic fiddle player. I play a really, really awesome fiddle. The problem is all the fiddles that I pick up, it's bad fiddles. It's always a bad fiddle. I'm a rock star fiddle player, but I just have yet to find a good fiddle that can actually put the music, you know. You know, I was going to learn how to play the violin, but I said, no to violins. And want world peace.
Never do that. Just clear it out.
I go to the bathroom later and corn comes out. I know where it came from.
I'm not using this app no more.
All right, so let's do it a little different now. What we're going to do this time is we're going to wire in a little different. A, B, C, D, E, F, G, H.
Shit just got real.
So when we wire this, we're going to go from our, we'll say the black wire line 1 into a switch, out of the switch into a load being one of the light bulb wires. We're going to come out of the light bulb wire and we're going to go into another light bulb wire. We're going to go out of that light bulb wire and go home to the opposite side of our source. Okay?
2 jobs.
And what we're going to do is this. We'll do a little simpler this time. We'll do amps. We're going to check amps. Does it matter where I check amps?
No.
Anywhere, right? So I'm just going to put amps.
Yeah, no matter.
Okay? Because it doesn't matter where I check it on that circuit, it's going to all be the same. And then let's check volts. We're going to check volts between A and H. We're going to check volts between B and C. We're going to check volts between D. Actually, let's do it like this. Between D and G. We're going to check volts between D and E, and F and G, and B and C. And we are going to do them all open and closed. Because we know there's no sense in doing any other combination because anything on this side would be the same, anything on that side would be the same. Does that make sense? Yep. All right, so what are you going to do?
Do it.
Do it. Yes. Yes, but don't burn it up.
Come on, man, let's get it wrong.